Hello dear friends, welcome my channel. Today's discussion is complex analysis branch cut method. So friends, this problem is the hypergeometric problem. Problem is 3f2 1 by 4 1 by 2 3 by 4 1 by 3 2 by 3 258 5 cube divided by 27 into 6 to the power 4. So how can I solve this problem, friends? The problem is very easy. It can be represented as this way: n equals to 0 to infinity 1 by 4 to the power n whole cube into 4n minus 1 triple factorial and 4n minus 2 triple factorial and 4n minus 3 divided by triple factorial, and after that it can be represented 1 by 3 to the power n whole square 3n minus 2 triple factorial and 3n minus 1 triple factorial and n factorial 256 divided by 27 into 5 cube divided by 6 to the power 4. Whole to the power n and whole to the power n. And now friends, after simplifications we can get this way: n equals to 0 to infinity 27 whole to the power n divided by 256 whole to the power n 4n whole factorial n factorial divided by n factorial and 3n factorial by n factorial and 256 divided by 27 whole to the power n and 5 cube divided by 6 to the power 4 whole to the power n. 5 cube divided by 6 whole to the power 4 whole to the power n. Equals to 4n n divided by 125 divided by 1296 whole to the power n. So friends, by the Cauchy's residue theory, 4n by n, it can be represented this way: 1 by 2 pi I integration c is the residue 1 plus z whole to the power 4n divided by z to the power n plus 1 dz. So this is my Cauchy's residue theory. So I can write this equation as this way: summation n equals to 0 to infinity 4n comma n. It can 4n comma n or 3n, however it can be written a lot of way. 3n I can write. So z to the power 3n plus 1. So it can be written 4n comma n 1 by 2 pi I integration c 1 plus z whole to the power 4n divided by 125 whole to the power n in z to the power 3n plus 1 into dz. And it can be written by the geometric series. It can be written this way: 1 by z 1 minus 1 plus z to the power 4 divided by z cube into 125 divided by 1296 whole to the power n, because as a plus ar plus up to infinity equals to a divided by 1 minus r, where r less than 1. Here you will see that 1 plus z whole to the power 4n into 102 to the power 5 whole to the power n and z to the power 3n plus 1 1296 whole to the power n less than 1, when mod z equals to 5. You can say mod z equals to 5, then it is less than 1. So friends, I can write this way. So it can be written mod z equals to 5. Yeah, mod z equals to residue. I can choose mod z equals to 2. Mod z equals to 2. Then it is less than 1. So okay. I hope I can clear. And now I shall go to solve another way. Mod z equals to 2, 1296 z cube minus 1 plus z whole to the power 4 125 dz. So it can be written this way. So if you see that if we will solve this complex number, then we can get mod z minus 5 and 1000. This equation equals to this 125 z cube minus 171 z square plus minus 105 z minus 25. So friends, our residue, according to the residue theory, that our residue is infinity and 5. Residue is at infinity and 5. When it is residue at infinity and 5, then I can get this way residue z tends to infinity z square into z minus 5 and 1125 z cube minus 171 z square minus 105 z minus 2. We can get easily this value is, you see that power is the denominator power of the z is highest, so this value is 0, and residue at z tends to 5. So whatever I get z square into z minus 5 125 z cube minus 171 z square minus 105 z minus 2. So we get this value, if we put that, this value is 104,432. So my equation 3f2, so whatever I get 3f2 2 1 by 2 and 3 by 4 4 1 by 2 1 by 4 1 by 2 and 3 by 4 4 1 by 2 1 by 3 2 by 3 and 256 divided by 27 5 cube by 6 to the power 4 equals to minus 1296 divided by 2 pi I minus 2 pi I divided by 432, and I get this value is equals to 3. So I hope I can clear this concept. And this is the complex method. Another way is directly you can get from the Google, the value is already given. Wolfram, you can check also the value is Wolfram. So next problem is very interesting. 2 to the power 2k k factorial whole square. So friends, this equation can be written this way: 1 by 3 k equals to 0 infinity gamma square k plus 1 gamma 2k plus 1 4 to the power k divided by gamma square 2k plus 1 minus 1 by 4 gamma square summation k equals to 0 to infinity gamma square k plus 1 gamma 2k plus 1 and gamma square 2k plus 1 1. So friends, this is the formula. Now we apply Legendre duplications formula. So friends, Legendre duplications formula, we need to remember Legendre duplication formula gamma 2z is equal to 2 to the power 2z minus 1 gamma z into gamma z minus half divided by root over pi. So friends, this formula I will apply. This note this. This is the legendary duplications formula. I use this formula in here. So what I get? I get friends 1 by 3 summation k equals to 0 to infinity gamma square k plus 1 gamma k plus half into gamma k plus 1 into 4 to the power k plus half divided by 2 divided by root over pi. It can be written this way. So I just apply this formula, friends, and divided by gamma k plus 1 gamma k plus 3 by 2 4 to the power k plus 1 divided by 2 root pi whole square. I just find out gamma square 2k plus 1 and minus half 1 by 4 summation k equals to 0 to infinity gamma square k plus 1 and gamma k plus half gamma k plus 1 4 to the power k plus half divided by 2 root pi divided by gamma k plus 1 gamma k plus 3 by 2 4 to the power 2 root pi equals to by simplification 2 root pi divided by 3 into 8 gamma half divided by gamma 3 by 2 by simplifications, friends, very simple, easy simplifications. K equals to 0 to infinity 1 whole square k Pochemar and half k Pochemar series. This is called Pochemar, and 3 by 2 k and k factorial, friends, and minus root over pi divided by 2 into 8 gamma half gamma square 3 by 8. Summation k whole square half a square k Pochemar and 1 by 2 k Pochemar and 1 by 4 k and 3 by 2 whole square k and k factorial. After that, friends, it can be written this way: 1 by 3 3f2 1 1 by 2 3 by 2 minus 1 and minus 1 by 4 3f2 into 1 comma 1 3 by 2 and 1 by 4. And this value equals to 2g, this value equals to 2g, and minus this value equals to 1 by 4 8g minus pi ln log 2 plus root 3 divided by 3. This is the value of this is, and this is the value of this. So I get this total 2. This is my answer. Now friends, we are going to solve another problem. The problem is complex integral and branch cut problem. So friends, whatever you see, we see that 0 to infinity pi sine px. So fz can be written z to the power p minus 1 divided by 1 plus z, and along the contour of the circle alpha and gamma, along the alpha, this is the alpha and gamma of radii alpha and r. Alpha, this is the alpha, and this radius is r, capital R, and lines AB and FG along x-axis, there is a simple pole at z equals to minus 1. So friends, you will see that's the simple pole z equals to minus 1. So residue f minus 1 equals to limit z tends to minus 1 z to the power p minus 1 divided by 1 plus z equals to e to the power I pi p minus 1. This is the value of the residue, and after that I shall go this way. You will see that AB, BC, CD, DE, BF, this way it is moving. So I get AB plus gamma plus FG plus alpha FZ dz. This way it is moved. By the Cauchy residue theory, I get 2 pi I e to the power I pi p minus 1. You will see this is the way. This is the way AB, after that gamma, this is the gamma path, after that FG, after that alpha path. So friends, on AB, z equals to x, and on FG such that z equals to x into e to the power 2 pi I. So whatever I get you will see this is the AB path when it is moving AB and FG. So this way one is x into e to the power 2 pi I, another is z equals to x. So I find out FG, AB, dz plus capital FG, dz equals to a to capital R x to the power p minus 1 plus x dx, and another is R2 a x into e to the power 2 pi I to the power p minus 1 divided by 1 plus x e to the power 2 pi I. X to the power p minus 1 divided by 1 plus x on the circle gamma such that z equals to r into e to the power I theta. So gamma fz dz equals to 0 to 2 pi r into e to the power I theta whole to the power p minus 1 divided by 1 plus r into e to the power I theta, as r tends to 0 infinity, so it is 0 as p 0 less than p less than 1. This and after that this value is 0. So and similarly alpha, when it is alpha fz dz then it is 0 to 2 pi as z equals to a into e to the power I theta, because you must remember that this radius is a, radius of the small circle is a, so a to the power I a into e to the power I theta and 0 to 2 pi a into e to the power I theta p minus 1 plus a into e to the power I theta into a e to the power I theta. So friends, for small alpha a tends to 0, a tends to 0, so a to the power p tends to 0, so this value is 0. So whatever I get x to the power 0 to infinity x to the power p minus 1 divided by 1 plus x dx into 1 minus e to the power 2 pi I p minus 1 dx 0 to infinity x to the power p minus 1 divided by 1 plus x dx equal to 2 pi I e to the power I pi p minus 1 divided by 1 minus e to the power 2 pi I p minus 1 equals to pi divided by sine p pi. This is the proved, friends, and this is the answer. Very simple, friends. If you just divided e to the power I p pi, then you can get this, because 2 pi I, because this value is equals to pi divided by e to the power minus pi p plus p minus 1 into e to the power minus pi I p minus 1 p minus 1 divided by 2I. This value is sine p pi. You can also write this way. This is the p pi. Okay, I hope I can clear this concept. Now L inverse. So friends, L inverse e to the power minus c root s divided by s equals to the Laplace inversion formula. Apply Laplace inversion formula. We have 1 by 2 pi I integration a minus I infinity a plus I infinity e to the power xs into e to the power minus c root over s divided by s ds. So since s equals to 0 is a branch point, integrand, we take a contour element sqst so that it does not incline any singularity. Therefore, by Cauchy's theory, integration Lm plus Mn plus Np plus integration Pqs plus St plus integration Tl into e to the power xs into e to the power minus c root s divided by s ds equals to 0, because we do not get any singular point. How? Because friends, you will see this is my movement Lm, this way, this is the moving, so you will not get any kind of, if you see that this is the movement Lm, after that Mn, after that Mp, after that Pq, after that St, after this the TL, LT. Along PQS S is equal to, now similarly St equals to S equals to r into e to the power minus I pi, r equals to r pi, on is equal to q, and op is equal to epsilon. On is equal to q, on np equals to rho divided by epsilon e to the power minus xr into e to the power minus ic divided by root over r divided by r dr. So friends, on is equal to q and op is equal to epsilon. I take on equals to rho, sorry, and op, so np and integration ht is equal to rho divided by epsilon, rho to epsilon e to the power minus xr c by root over r capital R into d capital R, and along the circle PQS, S is equal to epsilon e to the power I theta. We will go to the PQS, then we will take S is equal to epsilon e to the power I theta, and also the circle also the e to the power xs and e to the power minus c root over by sigma c root over s are both approximately 1. Since epsilon is small, therefore approximately 1, therefore PQS equals to integration p2 minus pi 1 by epsilon e to the power I theta epsilon e to the power I theta d theta equals to minus 2 pi I. Similarly, you see that mn, integration mn and tl, this is tends to 0 and tl tends to 0 as small r tends to infinity. This small r tends to infinity, so this portion is 0. I write the equation number 1. So from equation number 1, we get a minus ir, a plus ir e to the power xs minus c root over s divided by s ds. You will see this line a plus ir to a minus ir. This line is lm. And another factor is that, friends, there is the wrong this way mn portion is 0. mn and tl is 0 as r tends to infinity. where this portion mn portion, this path is 0 and this path is also 0, TL portion. So we get e to the power a plus IR, a minus IR, e to the power x into c root over s, and plus epsilon rho e to the power minus x capital R and e to the power minus IC root over R. Sorry, this is not I, this is plus I, e to the power minus IC root over R divided by capital R dr minus 2 pi I equals to 0, because we are already getting this value PQS is 2 pi I. So I hope I can clear this equation. And now epsilon tends to 0 and rho tends to infinity, and small r also tends to infinity. Then we have a minus I infinity and a plus I infinity 1 by 2 pi I e to the power xs minus c root over s divided by s ds is equal to 1 minus 2 by pi 0 to infinity e to the power minus t square sine ct by root over x divided by t into dt equals to 1 minus ERF c divided by 2 root over x. So friends, I hope I can clear, because this portion is if we divide by 2i multiply with 2i, so whatever we get the value is, this portion is sine c root r, because sine theta is equal to e to the power I theta minus e to the power minus I theta divided by 2i. So I hope I can clear, friends, very simple way. Thanks for watching.